Okay, so just to clarify, focal point's going to be at 4 centimeters, which means the center of curvature should be 8. All distances are measured from the mirror. We're going to place our object inside the focal point at 2 centimeters. We're going to give it a height of 2 centimeters as well. So go ahead and see if you can draw this out yourself. At least beam number 1. You should have no problem drawing beam number 1. Again, when you draw this, go all the way back to that vertical. If you reflect it at the mirror, you're just going to introduce some errors. Usually the mirror's curvature is very small compared to these distances, so it gets kind of exaggerated on your paper. Alright, beam number 2. If you notice, if you draw beam number, what's beam number 2 supposed to be? Through the focal point. Well, notice if we just draw it through the focal point, we're never going to even hit the mirror, right? If we just draw it through the focal point. So here's what you do when that happens. You take it, you line it up with the focal point, and instead of sending it away from the mirror, you just send it towards the mirror. So line up your object with the focal point, and we're just going to send it towards the mirror like that. And then it's going to reflect how? Parallel. So then you're going to reflect this beam parallel this way. So this was beam 1, this is beam 2. And then we're going to do the same thing with the center. Again, if you were just to send it through the center, it's never going to even hit the mirror. So what you do is you aim it with the center. You send it towards the mirror, and then just reflect it straight back. So beam 2, beam 3, bless you, you're going to aim it with the mirror and then reflect it straight on back. So if you remember from the previous drawing, what are we looking for? We're looking for the intersection of the 3 lines. However, what do you notice here? They're not intersecting. This is what we call diverging beams, where the beams are spreading out from each other. They're not coming together, they're diverging. So here's what we do when this happens. Here's the concept of it. Imagine that this is your eye right here, and you're looking at this problem. You're looking at these 3 beams. Okay? According to your eyes, how should light travel? In a straight line. So your brain cannot comprehend the fact that it's reflecting off of this mirror here. According to your brain, this beam, and this beam should be traveling in straight lines. So what you're going to do is you're going to take those 3 beams, and you're going to see what your eye sees. So I'm going to send these backwards. I'm going to project them back as my brain would predict they're doing. And I usually just draw these with dotted lines, just so you know there's not actually light behind the mirror. It's just my brain's interpretation of what's going on. And I'm going to do this with all 3 beams. Okay, and that's where you're going to find your intersection. So this point right here, this is where my brain thinks it sees the image, is right here. And remember, this is the tip of the arrow, tip of the arrow, tip of the arrow. So So just draw on the rest of the arrow. So here's my image located back here. So what are some characteristics of this image? It's larger. Good. So is this a real image or a virtual image here? It is virtual. And again, the reasoning is, if I go behind the mirror, if I put a screen back here, is anything going to show up? No. I only think there's nothing actually there. I only think it's there because of my brain. Okay? If you remove me, my brain, my eyes, is there anything there? No. It's only there because I think it's there. If we were to leave the classroom, there'd be no image there. On the other hand, if we left the classroom, would this still be up here? Yeah, so that real image would still be here, right? So that's actually there. This is only due to our brains, right? Our imagination of our brains. Okay, there we go. Let's measure it. Let's see what we get. Oh, is this upright or inverted? Upright. These are the characteristics they typically will ask you about on the AP test, the 3 big characteristics. So let's measure our HI. I'm getting about 4. About 4. I'm going to go with 4. HI equals 4. Let's get a HO. I'm getting a HO of 3.9, I guess. Not HO, sorry, DI. Getting a DI of about 3.9. Hopefully you're in that ballpark. 4.0, 4.1, 3.9, 3.8. Okay. And then let's find the actual values. So let's go ahead and calculate the true values. Oh, I chose nice numbers, so. What was our DO? 2?
Yeah.
So I can tell DI is supposed to be 4, right? Actually not 4, but negative 4. Yeah, when you do this out, you should be getting negative. So what does a negative distance mean? So negative distance means it's behind the mirror. Exactly. So we're on the opposite side of the mirror when we get these negative distances. Okay, let's go ahead and find our true HI. So it's like HI is positive 4. Yeah.
Oh, wait.
What's the meaning of a positive height? Okay, upright. Or right up. And what is an M? Well, we could probably do the M in our heads, right? If our object was 2, and our image is 4, what's our M? 2. Remember, the meaning of M is how many times larger the object is compared to the image. Or sorry, the image compared to the object. So we're 4, we started at 2, so that's 2 times larger. And it's positive. Again, positive means upright. Okay, question?